Welcome back to the C# tutorial. So we'll be doing some more programming today. Exciting. So let's just get started. So today we'll be taking this and turning it into a C# application. So what is this? So what does this do? So this takes this logging sheet. So when you're doing old tape-based cameras, you log all of your rushes. You could check in the corner for a video on old mini DV cameras, but you log your rushes like that. So if I do that, I can take all of my inputs, so up to number 2 there, and all of my outputs on this app, and it generates all of the durations of these clips. So 9 to 24 is 15 seconds. So we'll be turning this into a C# application. So rather than trying to do mathematics, who needs that, to figure out the durations of hundreds of these, you can instead just have it auto do it for you. So let's work on that. So obviously I'll be basing off of this one, so let's design our UI. So some labels, we want a list box, we want 3 list boxes, we want a button, numeric up and down, and then another label. So this is our basic layout. So now we'll obviously go through our boring stuff here. So what we can do here is we know this number needs to start at 25, just because it's 25 frames a second. So we can find that wherever it is. You see maximum, minimum needs to be 1. Maximum, let's just set it to 120, because we're not going to use slow motion for this. Actually, let's set it to 240, that'll do. Then we can set the value, instead of 1, it's 25. So next we want a group box. So these boxes you can chuck your stuff in there and make it look all nice and clean. Okay, there we are. So you can see this is all nice and clean now. So let's open this app and you can see the app looks fine, but we need to sort out all of the scaling. So on this one, I'm just going to literally set it to form border style, just fixed single, so it doesn't let you change the size. And then we can also set it to hide maximize and hide minimize. So it's just a single box like that. And I just realised that these list boxes are wrong. Wah. We actually want not a list box, a text box. Because a list box you can't input things on. So we can enable multi-line like that. Wah. So there we are. So now what we need to do is double click on generate and do what the button does. Okay, so let's declare some variables at the top. So we want to declare 3 lists. These lists will contain each of the lines that is within here. So that one of the inputs is one of the outputs, and we'll have one which will be populated with the final results that it needs to write back to the box. So we need to go public list, and these are a string. So we declare list by going list, these brackets, and then string. And we name it, so this is going to be in list. And this is a new list that is again strings. And since this is a function, we just need to do that. It's a function within C#, so that's hence why it doesn't look like a function, even though it is. So we need in list, out list, and final list. So these are the lists we're going to populate, and then again, so we want a public integer, which is our frame rate counter. I'll just set this to 25 as default. However, within our numeric up and down, we're going to go frame rate equals numeric up and down 1 dot value. And as you can see here, it's saying cannot implicitly convert type decimal to integer. However, the numeric up and down is a decimal value, so what we need to do is we need to put brackets around it and convert it. So we go convert to int 32. This is because C# is a very statically typed programming language. This means that each variable type is declared explicitly, so we have to say it's an integer. We can't really have a value which is, it's whatever it can be, like in Python. So that's the first thing. So as I change, if I just open this, as I change this value, it changes the variable. Within form 1, when we initialize, we can actually say our numeric up and down 1 dot value, we could set that to our frame rate. We could do this because let's say we set this to 15 in here. That value might not change if we have it set it to 25 default. So let's just put that so it auto sets it at the frame start. So now let's do some pseudocode. So when we click the button, we need to plan what we do. So we need to first clear all 3 arrays so it starts from scratch. Then we need to extract each line of the box to those lists. And then if our text boxes, this is also whatever's in our arrays, have the same value, because otherwise you can't minus one value from another if you're missing one of them. So if they have the same value, we need to for each element. So for each element within it, we need to remove any unwanted characters. So this means that it's all nice and clean, the code. Next, we split the values. So if you go back to our current timecode calculator, you see it has 4 areas separated by these colons. So we need to separate out those. So we split our values. Then we check that we have the right amount of values. Because if there aren't 4 values, so there should be hours, minutes, seconds, and frames. If we don't have the right amount of values, then it's not going to work, so we need to break there if it doesn't. Then we can go down 1. And what we need to do is we need to check it all passes. So we need to check that whatever's inputted are the right values, because if it says 64 seconds, it's obviously wrong, because that should then add on a minute if you're at 64 seconds, so it should really be 1 minute, 4 seconds. So we need to check it passes. And then we need to pass it to a float. So we have these 4 values now, and we need to turn it into a number with a decimal. So we'll use it as seconds. And then finally, want to add it back to the list. If they're still the same value, we want to add the lines to the list box. But if they're wrong, then we want to show a message box. So else, we want to show a message box. So let's start this. So up here, we want to clear our lists. So we want to go in list.clear. So why are we using lists instead of an array? Well, the problem with arrays is that they're statically defined, so they have a certain length. So it's not very good for adding values to it, changing values. It's very specific, so lists are pretty easier to use. Also means you get things like list clear, which is just so much easier than how you would do it about resizing arrays. So in list, out list, final list. Next, we need to actually add them to the arrays. So for an integer x equals 0, so we declare an inline variable here. Declare an inline variable, which is going to loop through every single line in the text box. So text box in dot lines, and we can count them. So just count. And x++. So we loop this for as many lines as in the text box. And then we can just go in list.add. So we can add the text box in. So the text box we're reading, dot lines, and we get the line we're currently on. And do exactly the same thing here. So there we are, we do exactly the same thing, but instead we want to get the output box. So next, we need to extract. So we've extracted each of the lines. So let's put that comment up here. So we can now go if our inList.count is equal to our OutList.count. So if the values are exactly the same, if there's the same amount of values, we can then loop through each of them. But if there aren't the right amount of values, let's do an else. And else we want to go messagebox.show check input the in and out point numbers differ. And we can set this to error. So let's do for each element. So again, we don't actually have to declare a different variable since it's inline within that area. So we technically can just go int x equals 0, x is less than in list this time. In list length and our text box length should be exactly the same. And then we increment x by 1. There we are. So we remove any unwanted characters. So this is where we're going to deviate from our standard. So we have sequence selection and iteration. We're going to separate from this point now. So let's just continue as we would. So string in point equals, and we're going to later create a function. So remove unwanted characters. And we're going to remove in list and the current element. And we're going to declare it as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the semicolon. So like things like A, B, C, D, etc. won't show up. This is for. So we do this for our in point and our out points. So let's declare a new function. So in line with this one here, so as you can see, private void. Let's declare one. So let's go private, and this is going to be a function that always returns a string. So I can actually type private string, and as long as it always returns a string, that will let me use it. So remove unwanted characters. So we have a string, and this is our input, and then we have an I enumerable, which is a character, and this is our allowed characters. So we can use an I enumerable, which is a character. We're defining it as a character here. So what we can do is we can type var filtered. So this is a variable. Var is a .NET structure that doesn't have to actually declare a data type. So it can be a complex type, an anonymous type, or a user-defined type. So it's just nice to have that in there. So we can go equals our input dot to a character array. So we turn it to an array of characters. And we can continue on the next line here just so it's nicely separated out. So where our character goes to allowed characters dot contains, and if it contains our character here, we want to add it to the array. Fairly simple. And then we can return a new string, which is our filtered value. So there we are. So that's our remove unwanted characters, and you see it works up here now. So next, what do we need to do? We need to split our characters. So let's go string in separated, so that's our separated out values, equals our in points dot split. And we can split these characters by our semicolon. So if we have the right amount of values, then we can break. So if in separated dot length does not equal 4, we do exactly the same for our out. So if our out separated length does not equal 4 either, then we want to break. So this means it just stops running the current code. So it's 4 because we know there's 4 parts to it. So now we check it all passes. So this will be the fun bit. So we again need to write a second function just to split it out, because it will be a pain in the ass to not have that as a second function. So down here, let's just create a boolean, and which is defined like that. Let's call it check parts. And we want to declare an integer, which is a number, and then a string, which is a type. So this string tells us whether it's like seconds or hours, how long it should be, and the number is just the float. The number is that part from the string. So if it says 64 and it's a seconds value, then you know it's wrong. So if our type is equal to like h, or is defined like that, or if the type is a minute, or if the type is a seconds, we know it's always going to be less than 60, because otherwise it would increment the next value. So we go if number is bigger than 59, and we want to return true on that one. And we can do an else if our type is a frame, and if the number is bigger than our frame rate minus 1, so our frame rate, so if our number is bigger than our frame rate minus 1, or if you want to do it a separate way, you can do if your number is greater than or equal to your frame rate. Either way will work. Then you want to go return true, and it always needs to return a value, so we need to return false here at the bottom. So if it's the right number, it will return false. Now this bit is going to get very long, so check it all passes. So we need to make sure that all of our values return false. So if we put that as a function, it says if it's true. So if it returns true, then it will work. So we want to put an exclamation mark in front that says, hey, if it returns false, then it will continue with this code. And within here, we need to pass our separated index. So we need to pass our values from here as an integer. So let's go integer 32 pass. And let's go in separated. So in separated, and that's our first index. And our type here needs to be hours. And then the next one needs to be minutes, and it's our first, and it's our second item. Seconds, and it's our third item. And frames, and it's our fourth item. So that's our first set of code. Then let's do the boring bit and just paste it in. And let's go out separated. Which means that it checks both of them. And I forgot a bracket there. Just make sure that your brackets are the right amount. And I've forgotten brackets on all those, so just make sure you put your brackets in the right place. So within here, we need to convert our separate values into a float. So that's just a number which is with a decimal. So let's say we have 2 seconds and 10 frames. That's 2.4, which is easy to convert back. So let's go float in. And here we just need to go float.pass, so we pass it as a float in separated. So we get our first index. Don't forget equals. So in separated, I get our first value. We pass it as a float. We go times by 60 times by 60, because that's how many seconds are in an hour. And then we plus our minutes onto it. So we do that. Plus our seconds, plus our frames, and those frames need to be divided by our frame rate. And we do exactly the same, but for our output. And then we can add to our final list. So we add, and we need to convert those numbers back to a timecode. So what we can do in here is declare a new function. So we need to create a new function, which is convert back. And within that function, we need to give it float out minus float in, and that the bigger number minus the smaller number, and that will give us our duration. So now we need a function, convert back. Let's just put it here. So this one will return a string. So string, convert back, and we just need our duration. So when we convert it back, we need to obviously get our hours equals something, minutes equals something, etc. So now our hours. Let's separate this out. So hours, we convert to an integer 32, so we just convert it to an integer. And within here, we need to math.floor. Math.floor, this means that it rounds it downwards always. Within here, we need to take our duration and divide it by 60 times by 60. This is because obviously, there's that many seconds in an hour. So then let's do exactly the same thing. So math.floor, but in here instead. So it's duration minus hours times by that. Because obviously we've divided it by here, but we need it in seconds. So we do that there. And then we divide everything by 60. Because obviously there's minutes. Seconds. So seconds, we need to go math.floor. Again, duration minus hours times by that number, minus minutes times by 60. And then we divide all that by nothing, because obviously we want it in seconds. And finally, frames. We need to go math.floor, so round it down. We do our duration. Duration minus our hours, minus our minutes, minus our seconds, divided by our frame rate. And finally we can return our string value. So this is going to be hours to string, and within here obviously we want a 2-digit number, so we can go D2, and that just means it's a 2-digit number, plus our semicolon, plus, so hours, we have our minutes, plus our seconds, plus our frames. So let's separate that out nicely. You see it's outputting our hours as a 2-digit number, then semicolon, minutes, semicolon, seconds, semicolon, and finally frames. So as you can see, convert back is working here. And then finally add the lines to the, well, that should say text box. So we have a string, which is an array of all of our different lines. So let's go new string. And we know how long this is, so we should use an array rather than a list. So this is our final list.count. So we create an array which is as long as our list. Take our final list and we copy it to our array. And finally, we take our text box with our duration in it, and we set its lines to be our lines variable. So with all of that, looks all fine. So as you can see, this is erroring out. So that means that I've made a mistake somewhere, which is as you do in code, as you do. So I know it has something to do with this, our in list and out list. So there's the error, you see. Out list isn't getting appended to. You can see here I didn't actually change that line. So this is part of debugging where you need to make sure you know what is doing what. So let's copy that in, and generate. So 10. That's obviously not working, because it seems to be cutting off the float value. So again, we need to debug this. So as you can see, I've put in a message box that shows our float out minus float in. And you can see it's outputting a float value, meaning that we are right. So it's just where the error is. So it's somewhere with this line here. Convert back. So let's see what we're doing. Are we putting in a float? So there's the error. It's a logic error, not a syntax or a casting issue. So what we're doing here, we're taking our duration, minusing hours, minusing minutes and seconds off of it, and then we're dividing it by the frame rate, when really that's too small. If you look at this again, when I paste in our values, I put that there, when our message box was there, let's do it again. As you can see, this is 25 frames a second. It should never give a value such as 0.08002. So we know that it's something something wrong with a logic error. So it should times it by the frame rate, because we're dividing, nothing, timesing. So now let's try it again. It's because the value was too small. Okay, so now we can check our project. So let's just grab some timecodes in here and put some timecodes in here. So that's it generated. Let's press start. Them in there, them in there. Let's just go right to the end, so the actual right values. So the end one is 2022-18-01. There is actually a bug with this this version of the timecode, not the one we just coded, that means that this is sometimes wrong. So those are the actual correct values. And what we can do is, let's say you have your document here, you can just paste in your values, and there we are. So it auto-fills it for you, which is quite nice. So there we are, that's our document. So that's this episode. You can see this time round we've used a lot of different types of functions. So we've created private strings, so it always returns a string. We've done booleans, string again. To be able to just do a standard function, we just do void, so that means it doesn't have to return something. You'll see that if I scroll up, our button press is a void, meaning that you don't actually have to return anything at the end of this value. But there we are. So there's our code. This is our function. Stay tuned for the next episode. I don't know what it's covering yet, but it's on its way. So you can see this is complete. This is very fancy and quite a complicated project for, a 5th project. Tune in next time, and I will see you later.